All right, guys, welcome back. This is Jonathan Gardner. This is the final section of Chapter 1 of Basic Mathematics. I hope you feel like you're hitting your second wind. You're really getting into math. You're kind of thinking about math. Maybe you're dreaming of math. Maybe you're seeing the numbers dance in your head, hopefully. Homework for the last problem. I'm wondering what to do about that. If you had problems doing the last homework section, you really should reach out for help. They're not terribly difficult, but they do stretch your brain. And if you need to get your brain stretching in that particular direction. So without further ado, though, let's get right into multiplicative inverses. This chapter is going to feel like there's only one really new thing here. And he introduces this in the beginning. So the equation, he says rational numbers satisfy one property that which is not satisfied by integers, which is that for any rational number a, if a not equal to 0 is rational, okay, then there exists a, and we write to the minus 1, you'll see why that is later, such that a times a to the minus 1 is equal a to the minus 1 times a, which is equal to 1. All right? So this is the multiplicative inverse. It doesn't happen for integers. There's no integer that you can multiply 2 with that would give you 1. It only happens for rationals. And we'll find out later it happens for reals as well, but we'll do reals in the next chapter. Reals are a very interesting subject in their own right. Let's prove this. So let's grab a different colored marker. Let's use this green Sharpie, this fine green Sharpie. Okay, so we have a equals m to the n, and we want to prove that there is a number that you can multiply this by. So a times a to the minus 1 has to equal 1. So that would be m to the n over something has to equal 1. And what could that possibly be? Well, let's guess that it is n over m. And sure enough, the factors all cancel out, and you're left over with 1. That's the proof. There it is. So a to the minus 1 is equal to n over m. Note that m cannot be equal to 0 and n cannot be equal to 0, but they're both integers. Okay, so this is called the multiplicative inverse. I'll write that down here. Okay. Why didn't we introduce this earlier? Well, we really couldn't. Because we were talking about integers and we weren't talking about rationals. Now that we're finally talking about rationals, we can talk about the multiplicative inverse. Leave that there. Example. So what number times 1/2? So we're going to start with 1/2 and we're going to multiply something and we're going to get 1. So what number would satisfy that? Well, let's put the 2 on the top and the 1 on the bottom. Or in other words, 1/2 times 2, that's going to equal 1. The multiplicative inverse of 2 is 1/2, and indeed the multiplicative inverse of 1/2 is 2. Okay. Here is another proof. Let's suppose that we had a times b is equal to 1. This would imply that a is equal to b to the minus 1, or b is equal to a to the minus 1. So they are each other's inverses. All right. Proving that should be fairly easy. So if we start with ab equals 1, and we multiply both sides by a to the minus 1, let's say. Okay, so then we end up with, this is 1 times that. So then these two cancel and become 1 by definition, right? So we get b is equal to a to the minus 1. And the same token, if we start with ab equals 1 and we multiply both sides by b to the minus 1, then these two cancel and become 1, so we get a equals b to the minus 1. Fairly trivial to prove. Relies on us multiplying both sides by a number. And next one that's interesting. If ab is equal to 0, I'll just draw a line here, then a is equal to 0, or b is equal to 0, or both. Okay? All right, why do we know that? Well, let's suppose that we had ab equals 0. and we multiply both sides by b to the minus 1. We assume that b is not equal to 0. We assume that b is not equal to 0. It only works if it's not equal to 0. There's no multiplicative inverse for b, for a number that is equal to 0. So this is b times b minus 1. So this is a equals 0 times b minus 1. 0 times anything is a 0. Or if we assume the other hand, that a is not equal to 0, then we get a to the minus 1. A, let's make that a little bit more beautiful, equals a to the minus 1 times 0. So b has to be equal to 0. Okay. We are just sailing right through this very quickly. We can write this. We can say a to the minus 1 is equal to 1 over a. All right. Is that what he says? No, that isn't what he says. That's what I say. So yeah, we're just going to say that, hey, when you say something to the negative 1, so that will give you the behavior that a to the a minus 1, because then this is what it looks like. So if, let's say a is m over n, all right, then 1 over a would be 1 over m over n, okay, right? And does this times that equal 1? Well, let's take m over n times 1 over m over n. That does indeed equal m over n, which is equal to 1. So yes, this is equal to a to the minus 1. Okay, boom. That was easy. Do I need to mention something else here? Cross multiplication works. So I'll pull out the cross multiplication card. This also works for rational numbers, which he takes too much time to prove that using the multiplicative inverse as a proof. Let's do that really quick. Let's prove cross multiplication for rationals using the proof. So we have a over b equals c over d. And this implies that AD is equal to CB. All right. So we can rewrite this relationship A over B equals C over D as A times B to the minus 1 is equal to C times D to the minus 1. Okay, and we multiply both sides by dB. So we get A times B times D, B to the minus 1 times dB, C times D to the minus 1 times dB. These two terms become 1, these two terms become 1, and so you get AD is equal to CB. So starting with this, we rewrote it this way, and we multiplied both sides by dB, and we got the relationship AD equals CD. And that's it. If we start with AD equals BC, and we want to go backwards, then what we can do is multiply both sides by b to the minus 1, d to the minus 1. So we go AD times b to the minus 1, d to the minus 1 equals BC, b to the minus 1, d to the minus 1. And so these two terms cancel here. These two terms cancel here. So you get a b to the minus 1 equals c d to the minus 1, or a over b equals c over d. Not very complicated proofs. Example time. Let's do an example. So we have 3 over x minus 1 equals 2. Let's solve for x. Let's use cross multiplication. So we can imagine that there's a divided by 1 at the bottom there. So 3 times 1 equals 2 times x minus 1. Notice we're putting parentheses around here. It's not 2x minus 1. It's 2 times x minus 1, which sounds the same, but it's not. Distribute the 2. We get 2x minus 2. At least that's, I assume, what he's doing. And then he moves the 2 to the other side, so we get 3 plus 2 equals 2x. Remember, terms, when they cross the equal sign, they flip their sign. So we have 5 equals 2x. And let's do cross multiplication in reverse. So we get 5 over 2 equals x. X is 5 halves. That was it. Let's go ahead and plug in x and see if that works. So we get 3 all over 5 halves minus 1 equals 2. 3 all over 5, and then the 2 times minus 1, so it's minus 2. Remember how to do addition. of fractions with the wrong denominators. You multiply across, and then you multiply across. That'll make sense to somebody, I assume. Equals 2. Let's remember this one's the bigger one. Okay, so 5 minus 2 is 3, so it's 3 over 3 halves. And this is 3 times 3 halves to the negative 1. And so that will give you 2/3. Cross off the 3's because they cancel, and you get 2 equals 2. So plugging that in works. Excellent. Moving right along. Square. Cancellation for cross multiplication. Let A be a rational number not equal to 0. If AB equals AC, then B equals C. So we already have the cancellation rule. Can we reuse that just with rationals? Let me try to find it really quick. Okay. So it's something like that. It says that you can cancel. He starts off differently. He says if AB equals AC, then B equals C. So he says if AB equals AC, then B equals C. Let's prove that. This should be pretty easy to prove. If you don't know how to do this, then you haven't been paying attention, have you? So we start with AB equals AC. We multiply both sides by a to the minus 1. These two cancel, become 1, and so we get B equals C. Very easy. Let's rewrite this as a ratio. So oh wait, listen, no if there. AB over BC equals this. AB over AC equals BC. So we cross multiply this one. So we get AB over AC. Let me move this out of the way. Equals BC, and cross multiply. So we get ABC equals BAC. And sure enough, that's equal. So that checks out through cross multiplication. That checks out. So it is true that those two things are equal. If A over B and C over D are two quotients of rational numbers, when B is not equal to 0 and D is not equal to 0, then we can put them over a common denominator and write AB equals AD over BD and C over D equals BC over BD. So this is basically going into how you can add rational numbers that are ratios. Ratios of rational numbers. Here we go. Remember this? Let's put that down there. So it says, suppose that we have A over B. Let's use green. So we have A over B. And we can rewrite that as AD over BD. And we also have C over D. And we can rewrite that as BC over BD, where A, B, C, D are rational. And B is not equal to 0, and D is not equal to 0. Okay? So if we wanted to add AB plus C over D, we would get AD over BD plus BC over BD. Noting that the denominators are the same, we can just add the tops. Okay? Which should look a lot like this, except with slight differences, because they had A over B and C over D. But you can kind of see that it still ends up being BD. The bottoms multiply, and then you get this times that, sure enough, B times C, and that times that, so A times D. So multiply the bottoms across, cross multiply the top two terms, and then add them together. That's how you add two fractions, two ratios of rational numbers. Example. Ooh, this is getting fun. I'm going to use this pleasant blue. I'm color ignorant. I like this blue color. This is cool. Okay, this is really cool. And this is when it starts to get really fun. Down there. Show that 1 over x minus y plus 1 over x plus y is equal to 2x times over x squared minus y squared. Okay. To do this, we're just going to follow this rule. So we're going to take this guy, multiply it by the top. which is 1. This guy multiplied by the top. And we're going to multiply the bottom. So we have x minus y, x plus y. And if you remember when I told you to memorize what you get when you multiply a plus b and a minus b? That's this case down here. And if you need a refresher course, this is what you do. You take x plus y times x minus y, and you distribute this. So you get x plus y times x minus x plus y times y. Okay? And then you distribute this way, so you get x squared plus xy minus xy minus y squared. These two terms cancel, and so you get x squared minus y squared. Now when we add these terms, we get 2 x's, and this is a plus, and that's a minus, so they cancel each other out. And this is what you're left with. Okay, therefore we've proved it. We've shown that using basic principles. Pretty dang fun stuff. The quotients 1 over x minus y and 1 over x plus y make no sense if x minus y equals 0 or x plus y equals 0. So note, x plus y cannot equal 0 and x minus y cannot equal 0. Okay? In other words, x cannot equal y and x cannot equal negative y. Actually, this one goes this way, this one goes that way. Okay? And so even though we didn't state that, you have to, when you look at these equations, you have to assume that's true. Okay? And if this is true, then x squared minus y squared. Also, x squared minus y squared cannot equal 0. So x squared cannot equal y squared. In other words, x cannot equal plus or minus y. Okay? Pretty simple stuff. Okay, solve for x in the equation. Shall we use a new color for this? I think we shall. Line out the paper, make it neat. Put a pin on there so it doesn't keep bumping around. Stay still. All right. Oh, here's a nice little lavender color. Let's see how this looks on the camera. Solve for x in the equation. 3x plus 1 all over 2x minus 5 equals 4. There are homework problems. There's a lot of homework problems just like this. So pay attention to how we solve this in the book. So first we cross multiply. So 3x plus 1 equals 4 times all of 2x minus 5. Remember there's a hidden denominator under here? Right? So it's 1 times 3x plus 1. No change there. And 2x minus 5, the whole thing's times 4. Okay? Next we're going to distribute this 4. So this is going to be 8x minus 20. All right? We're going to move the x's to one side and everything else to the other side. So let's move we have a 3x plus 1 here. Let's move that guy this way, and let's move this guy this way. So the sign's going to change, so it's going to be 1 plus 20 equals 8x minus 3x. So we get 21 is equal to 5x. Okay, and let's do the cross multiplication in reverse. We have a 5 and an x. Let's bring this 5 down. So we get 21 over 5 equals x. That's the solution. Let's go and check our work. Let's plug 21 over 5. So we have 3 times 21 over 5 plus 1. I'm going to put parentheses over what we substitute. My handwriting is terrible. I'm sorry. Minus 5 is equal to 4. It's supposed to equal 4, right? So we get 3 times 21 plus 5 all over 5. Remember, we're doing the addition rule. We have to multiply the other side by the bottom. All over 2 times 21 over 5 minus 5 times 5 is 25. That's supposed to equal 4. Let's draw the bigger line here. So we have 3 over 5 times 26 all over, let's see, this is 42 minus 25. That's not easy to do, is it? 30, no, it's 20, no, it's 16. 16, 17. I think it's 17. Let's see, 25 plus 5 plus 7 is 12. Yep, that's a 2. And we're supposed to do 4, so it's 17 over 5. Okay? And let's go ahead and bring that one upstairs. So let's move it over here. So we have 3/5 times 26 times 5/17. Remember when we bring it upstairs, we're flipping it to be the inverse, and so the inverse is upside down. Okay? So we have a 26 upstairs, we have a 3, we have a 5. The 5s can cancel. Now we have 3 times 26 is supposed to equal 17. And I don't think that's going to work. I made a mistake somewhere, didn't I? Well, let's see if I can quickly identify where I made the mistake. 21 over 5 is the x according to the book. So I had 3x plus 1. 3x plus 1. So that's 21 plus 5 over 5. And 2 times 21 over 5 is 2 times 21 minus 40. I bet you it's here. 42 minus 25. See, I don't think that's going to change anything. I'm going to borrow the 1 there. So that's 17. That's definitely 17. So there's a 17 in the downstairs. There's a 5 in the upstairs. And that's a 26. Something ain't right here. I did something terribly wrong. Something's wrong with me. X is 21 fifths. Yes, I figured out what I did wrong. It is not 3x plus 1. There's no parenthesis here. So this is actually, do it over again. So it's 3 times 21 over 5 plus 1, all over. See, it's 3 times that plus 1. And it's going to be 2 times 21 over 5 minus 5. So that's going to equal 4. So then we have 3 times 21 plus 5 all over 5, all over 2 times 21 minus 25 all over 5. So we have 1/5 over 1/5. We're going to flip this upside down. So it's going to be 3 times 21 plus 5 over 5 times 5 over 2 times 21 minus 25. Okay. So these 5's cancel. So I get 3 times 21 is 63 plus 5 all over 42 minus 25. That's 17. So 63 plus 5 is 68 over 17. And indeed, 68 divided by 17 is 4, so it checks out. Okay, that was my problem. I had an extra parenthesis. Ha ha ha. All right, speed. Let's talk about speed. Kids, don't do drugs. Ha ha. That's a bad joke. Okay, so speed measures distance over time. So, or the other way to think about it is how far do you travel if you're moving at a certain speed at a certain amount of time. I'm going to write this down on a separate card. The distance you travel is equal to your speed times the time you travel, assuming constant speed. Okay. So if we can also write speed equals the distance you traveled over the time you traveled. Okay. So if you traveled 5 miles in 1/2 an hour, how fast were you going? Let's use a nice blue again. I like the blue. So we traveled, speed is equal to 5 miles divided by how many? 1/2 of an hour. 1/2 of an hour. So we're going to get 5 over 1/2. That's a 1. Miles per hour. So that is going to be 5 times 2, because when we bring it, remember we have, if it's A over B, that's the same as A to the B minus 1. And B to the minus 1 is equal to, if B equals M over N, then B to the minus 1 is N over M. Okay? So in this case, though, 2 comes from the 1/2 being flipped upside down. So we have 10 miles per hour. Okay? That's the speed for 5 miles in 1/2 of an hour. A person takes a trip and drives 8 hours, a distance of 400 miles. His average speed is 60 miles on the freeway, 60 miles an hour, and 30 miles per hour when he drives through town. How long did the person drive through town during his trip? To solve this, let X be the time. So X is how much time he spent through town. Is the time spent through town. He drives 400 miles total. And he does that in 8 hours. Okay. 60 miles per hour on the freeway. And 30 miles per hour in town. So we can write an equation for the distance traveled. We can say he traveled 400 total, which starts with the distance is the speed times the time. 30 miles per hour times the amount of time he spent in town, 30 times X, plus 60 miles per hour times the amount of time you spend on the freeway, which is 8 minus x. Okay. So let's go ahead and simplify. So we have 30x here, plus 60 times 8 is 480, minus 60x. So we combine 30x and 60x, minus 60x, we get minus 30x, plus 480 is equal to 400. Let's move that to the left. We're going to move that to the right. So we get 30x equals 480 minus 400. So we get x, 30x is equal to 80. Let's use the cross multiplication reverse. We get x equals 80 over 30. So we get 8/3 of an hour. That's how long you spent in town. Another example, the radiator of a car. Let's use our blue. We did blue. Let's use our purple pink color. A radiator of a car contains 8 quarts of liquid. So 8 quarts of liquid. Okay. Consisting of water and 40% antifreeze. So it's H2O plus 40% antifreeze. How much should be drained and replaced by antifreeze if the resultant mixture should have 90%? So should have 90% after draining. And they're going to use X. Okay? So they're going to drain X. So after draining X, you have 8 minus X times 40% antifreeze. Okay? And then you're going to add X times 100% antifreeze. Okay. And it's going to be 8 minus X times 60% H2O because it's water antifreeze. And so we want to get to 90% antifreeze. So 90%, we want 90%. So we start with 40 times 8 minus X, 40% times 8 minus X. And we're going to add X amount of antifreeze, right, which is 100%. And then we want to get 90% of 8 quarts. Okay? So we're going to add X quarts of pure antifreeze to get 90%. So percentages, really X percent, well, let's write Y percent is equal to just Y over 100. That's all it is. So we have 40 over 100 times 8 minus X plus X is equal to 90 over 100 times 8. And we want to solve for X, so we get 40 times 8 over 100 minus 40 times X over 100 plus X equals 90 times 8 over 100. So we can factor out an X here. So let's move this to the left. Yes, let's move this to the left. Let's keep this all here, and let's factor out an X. So we're going to have X times 1 minus 40 over 100. I reverse this order. Is equal to 90 times 8 minus 40 times 8. And these are all over 100. Okay, it's minus because it went across the equal sign, and I factored out the X using the distribution reverse. Now what are we doing? So we have X equals, and we could probably simplify this. We can put this all over 100, right? We don't need that right there. 40, there's a factor, so this is 8 times 90 minus 40, so that's equal to 8 times 50, which is 400. So we have basically 4. We have 400 over 100, which is 4. Okay. I hope this isn't confusing at all. It's a little bit confusing for me. So X equals 4 divided by 1 minus Well, let's do this. This would be 100 over 100 minus, that's 60, minus 60 over 100. Let's do that. Minus 60 over 100. This is equal to 4 times minus 100 over 60. That's going to be minus 40, 400 over 60. We can cancel out the tens. There's a 2 here, leaving a 3 behind. There's a 2 there, leaving a 20 behind. So we get minus 20 over 3, which is definitely the wrong answer. I made a mistake somewhere, didn't I? I made a big mistake. The answer is 20/3. How did I make a mistake? Let's do it again. This time I'll be more careful. We drain out X quarts. So we started with 40% and 8 minus X quarts. And then we're going to add an X more quarts of pure antifreeze. And we want to get to 90% times 8 quarts. Okay? So we get 40 times 8. Distributing it out. Minus 40 over 100 times X plus X equals, and let's just leave that, 90 times 8 over 100. Okay? Let's move this to the right-hand side. So we get minus 40 over 100 X plus X equals 90 times 8 over 100 minus 40 times 8 over 100. And we get X times 1 minus 40 over 100 equals all that. This is going to be 50 times 8 over 100. Okay, I just did the distribution, and let me just spell that out for you. It's 90 minus 40 times 8 over 100. I pulled out 8 over 100 for the factors, and this is 50 times 8 over 100. Okay, so this is X. So this is 100 over 100. 100 over 100 minus 60 is 60 over 100. I see where I went wrong. Equals 50 times 8 over 100. And now I do cross multiplication, so we get 50 times 8 over 100, all over 60 over 100. So I'm just going to multiply by the inverse, okay, rather than dividing by the regular. These hundreds cancel, and we get 5/6. The tens here cancel, so we get 5/6 times 8. Well, we can cancel out that as well. There's a 4, there's a 3 left over, so we get 20 over 3. X is equal to 20 over 3. And that's the correct answer according to the book, I believe. Let me double check. I did it correctly. Yes, 20 over 3 is correct. You could put this in a lower form, which basically you divide 3 into 26 times. You get 18, and you'd have 2 left over, 6 2/3 quarts. So when you go to the hardware store, you can say, I want 7 quarts, and I'll save a third in the last one. All right, I think that's it for this chapter. Yeah, this is basically how you solve the homework problems. I've given you a blueprint for this. I want you to tackle the homework problems for chapter 1. Probably go review the chapter. Remember the important equations. I won't put together a review video. I'll let you guys do that on your own. And we'll continue next time with chapter 2. We'll cover reals. Anyway, guys, thanks for watching. I hope you enjoyed yourselves. I hope you learned something new. I hope you stretched your imagination with math. And I hope especially you're doing the homework problems and you're struggling with those. If you have questions about the homework, please ask in the comments below. I would love to help. Take care and bye-bye. Hey guys, thanks for watching this video. This video is part of my series on Sergey Lang's Basic Mathematics. You can click here to watch the rest of the videos in the playlist. You can click here to learn more about me, and you can click here to support my channel. Thank you so much. Bye-bye.